Hi everyone. Today we'll look at the Raspberry Pi 5, Model 5, its specification and installation. And we're going to use some of the features of Raspberry Pi. This slide explains all the components of the Raspberry Pi Model 5 that you received. You may be able to see that. It has two USB ports available, and if you need to connect the Ethernet cables, then that is also possible. And camera modules here. From this Raspberry Pi, you may display two HDMI connections, and then USB Type-C power adapter here, and UART connector. UART connector may be used for wireless communications, but we don't do that here. On and off button and PCI expression interface, and then wireless 802.11 AC wireless connections and Bluetooth 5 connections available. And this is the processor. And then I believe the Raspberry Pi that you received is 8 gig, which is the high end of the HDMIs. 8 gig, the SRAM, so-called, the memory is available. And I/O controllers, and then fan connector if you want to install the fans. Specifications of a Raspberry Pi 5. The system on chips board available, BCM board, Broadcom BCM board, and CPU architecture, Qualcomm ARM Cortex A86 64 bits. Clock speed is 2.4 gigahertz. If you do some of sensor network, then you may need to understand the BCM mode, but in this course we don't do that here. Graphics, GPU module is available, and the memory 8 gig. Storage, I believe the Raspberry Pi kit that you received includes micro SD card, so you can use this. You can have a higher the storage size of SD card also available. For example, 512 gigahertz SD card. I used that a couple of times. If you need to store the massive data on your Raspberry Pi. And connectivity, Ethernet connections, USB, 2 ports available, wireless, 802.11 AC Wi-Fi, and then Bluetooth. 2 video outputs and power supplies, 5 volt to 5 amp. So you can use the adapter included, comes with your kits. Okay, so it's that adapter at one side from the wall, 110 volt. Output from that adapter is 5 volts that goes into your Raspberry Pi. 5 amp, which is not really low at all. 5 volt is good. Right. Some other cases, if you use external power, high power consumed sensors attached to this, then you can use external power supplies, either 5 volts or 12 volts or 3.3 volts. The amp maybe 12 amps or 9 amps, whatever required from that sensors. Sensor network is not for this class. Camera interface available. GPIO pins. I believe you have 40 pins available. Here is a GPIO, general purpose IOs. Okay, so you need to see the specifications of each pins based upon the mode, PCM mode or other pinout modes, whichever available. So yeah, thermal management. This Raspberry Pi Model 5 it runs the high speed of processors and high size of the RAM memories. Therefore, it generates hits. I believe some of the thermal the management kits also comes with your the Raspberry Pi, so you can attach it to some of the components, so whatever it is set. Okay, maybe I believe there is one goes with this processor and this RAM. I believe, yeah, somewhere here you need to attach that. Operating systems, Raspberry Pi OS is needed, and your SD card already had that Raspberry Pi OS, so you don't need to do any additional. Form factor, same size as the previous Raspberry Pi models, meaning that it is compatible with the most existing Raspberry Pi 4 cases and accessories if you want to use. Size-wise, it remains the same. Okay, this Raspberry Pi Model 5. But a couple of the classes ago, I showed to you the Pico size of Raspberry Pi. Raspberry Pi Pico 2, which is a very, very small ones, that you can load your program, and when the power is on, the program automatically runs. Therefore, any electronic devices, home electronic appliances may include that. Even TV sets. If it is a smart TV, then this kind of control, microcontrollers embedded in it. Okay, installations. Raspberry Pi 5 assembly is trivial. OS installation is pre-installed. But if you need to reinstall it, if you want to use other SD card, then you have to install Raspberry Pi OS on your SD card from your laptop. Okay, you need to install Raspberry Pi OS from your laptop. I believe the Raspberry Pi kits that you receive has adapter, SD card adapter. It looks like that is the USB the connector, and the other end of that connector that can receive SD card. So plug that onto your laptop, and then you can install it. So if you want to do it, this is the configurations. So if you use your pre-installed SD card or SD card that you installed Raspberry Pi OS, once SD card is available, then plug into your Raspberry Pi and then supply the power. Then there's a welcome messages, and then ask you to set the language, keyboard, and time zone. You can set it, and then username and password. You can set it also. My case, I reset it Jyun rather than Pi, and then you can set your password. I covered that, my password. And then networking needs to be set. Here, Ethernets. So select a Wi-Fi network. In my case, Ethernet 1 disk, and then put the password. Okay, and then you can also bring up your the web browser. You can choose Chromium or something else, but I use Firefox. Software updates, I recommend you to do that. Updates and upgrade. So download the software packages takes longer time. I believe maybe 10 to 20 minutes. And then you can install it. Once you configure your Raspberry Pi OS on SD card, then you need to restart your Raspberry Pi, restart it, then you will have this kind of the images, which means it is ready to use. This is some of the GPIOs. So GPIO board pinouts, then you need to use this configurations. If you want to use the BCM mode, then you need to use this. As I said, at this moment, you do not need to. In this class, at least. Okay, if you want to install a Raspberry Pi OS on your new SD card, general SD card, not the SD card that comes with this Raspberry Pi, then buy SD card. Then you can use two things that you could do: adding knobs, new out-of-box software. You need to follow this, or this is handy. I recommend you to go this second way, using a Raspberry Pi OS imager. So you need to download the imager. That's easier. Okay. Once you download it, then that SD card, no, Raspberry Pi OS imager is available on your laptop. This is something that you need to do on laptop, okay? Still laptop on. Because your Raspberry Pi is not ready to use. Now you need to do SD card. Okay, so this program needs to be available on your laptop. And then first thing that you need to do is the SD card formatting. If your SD card is brand new, nothing in it, then usually you do not need to reformat it. But if you want to install Raspberry Pi OS on the SD card that you have used for other purpose, then you need to format your SD card. Okay. There is a SD card formatter. This SD formatter from sdcard.org. You can download it and you can format it. This is a number one approach. This is number two, imager approach. So you need to download this imager. Then open that. Once you download this Raspberry Pi imager, execute it, then you will see this. Then you need to choose OS to Raspberry Pi, 62 bits or 64 bits, depending upon your Raspberry Pi. Your Raspberry Pi right now is 64 bits, so you can use 64 bits. Or you can use 32 bits. This is also possible. And then storage is, you need to choose SD card. And then start to click this right button. Then you can install. Okay. This is done. Okay, now you are ready to, your SD card is ready. Then you need to unplug your SD card from your laptop and plug into your Raspberry Pi. The bottom of a Raspberry Pi, there is a small slit. Then you can see, I believe that is from this. This is, for example, at one side. The other side, the bottom of, I think, this place, there is a small narrow slots available that can fit the SD card. You can plug that SD card. The SD card that has Raspberry Pi OS installed. And then you can run your SD card. Now, your so far, your Raspberry Pi has two, well, actually four USB ports. So initially, you may need extra mouse and extra keyboard, and also the terminals. Okay, and then you configure your Raspberry Pi OS on your Raspberry Pi device. Everything is ready. Then we need to set up virtual network computing. Virtual network computing is convenient, but not mandatory. If you continue to use separately using your keyboard, mouse, and terminal, extra terminal. If you do not have extra terminals, you can use your smart TV. Anything that you can display, you can directly plug where there is HDMI connection is available from your Raspberry Pi to your terminals. So it'll be a separate computer. You can continue to use that way. Another thing that you can use is if you want to include your Raspberry Pi terminal on your laptop. So on your laptop, you can run any applications that are available on your laptop. At the same time, Raspberry Pi terminals on your same laptop terminals. That is possible if you set up virtual network computing, VNC. Currently, the VNC, the version is 7. VNC version 7 or above, then it is not free anymore. The trial version only available. Trial, if you put your, I think, your credit card number, then I think 7 days free. But if you receive older version, version 6, then I think you can use without having to do it. You can find it from, I think, version 6 of VNC somewhere. So I have a version 6, so I'm using that. What you need to do is, again, you have to install the real VNC viewer on your laptop. Your Raspberry Pi, it has a VNC already, so you have to enable it on your Raspberry Pi. On your laptop, you have to download it and install it. Okay? So I'll show to you. So once you install this the VNC viewer, the version 7, but I have a version 6, so I will show it to you how I can use. So this is the ones, and I do talking. Okay, so I'll stop this and I'll show you. Applications here, I have a VNC viewer. Double click it, then you have this. And also, how do I know this? I know this from my Raspberry Pi, but I will show to you how you can get that number, that IP number from your Raspberry Pi before you are connecting using VNC. Okay. So I'll show you. Once you know the VNC, then and as I said, you should. What is it? Somewhere here. I already said here. Right. Then it asks you to. Once you enter this, then ask you to see if you the VNC server now by clicking this continue, then it will ask you to enter the user ID that is available on your Raspberry Pi and password. Okay, so I already had that. So here's what you need to do. Suppose you are here your Raspberry Pi. First, this is your Raspberry Pi. Let me close this and then start. On your Raspberry Pi, then of course you have your the Wi-Fi available, and then click on this Raspberry Pi image. Then there is a preference, and then Raspberry Pi configuration. If you click this configurations, then on top, multiple tabs available, system, display, and interface. I want you to click interface, and then click SSH and VNC. Okay, you can you can connect from your terminals to your Raspberry Pi using SSH, or you can show the image of your Raspberry Pi through VNC. So you need to, by default, this is not available, not enabled. So you need to click this so that that is available, and then click OK, and then reboot it. So go here, and then you can reboot. After you reboot it, and then come back here, the terminal. Open the terminal, and then type host name -i. I believe I wrote that here. On terminal, sudo, either this, you can do sudo Raspberry Pi config, or you can simply click this and then configuration. The same thing, but this is easier, graphical mode, so you can do this. We already did that, right? After you have done, then how can we get the IP from this Raspberry Pi? IP is needed to connect your VNCs. That IP you can get from your Raspberry Pi terminals using the command line, hostname -i, hit enter, then it gives you IP number. This IP number should be entered from your laptop. This is your laptop. And enter, then that is connected to this Raspberry Pi. This is the Raspberry Pi terminals. Look here, see here, this is the IP number. Once I connect to Raspberry Pi, and it shows VNC viewer. So this is a Raspberry Pi images. All others, this is a laptop images. Okay. What else I need to do? After you have that, then remember that Raspberry Pi needs to play as another server. Like we have already set up the server on the Google Cloud, right? We have also another server running on Raspberry Pi, which is mobilized. For example, if you have delivery trucks, then delivery truck can carry Raspberry Pi, or truck somewhere Raspberry Pi is installed. So it has wireless communications, and also you can talk to Google Cloud, or you can talk to your laptop. So Raspberry Pi should have some server running. The server that we want to run on Raspberry Pi is TCP server. So I included the TCP server here. This is the code. I want you to simply use this. Okay. This is a Python code. I defined the class TCP server, and then a couple of the methods. So initialize and bind the method and talk. So I create an object of TCP server. This is a class, and this is an object, server 1. Because this is an object of a TCP server, I can invoke a method that's defined with this class and available, so that I first bind. When I bind, I need an address and port. As a server, I can designate a specific address, which means for the security purpose, I do not want to open my server to anyone but this specific IPs. But if you open this means quote and unquote immediately. Don't put any space within the quotes. If you put space, then you may have an error. Not an error, but it may not connect. But port number you can set up. I put here port number 2545. This course number is 545, right? So I put the 2545. That is a port number. So that is bound here. Once your TCP is open to a specific port number, then I can start to talk. So I say talk. Then your TCP object listen. Okay. I put here listen number 1. So I want to listen one at a time. I can put here number 7. Then, hey, I want to listen 7 different clients. But I have simply number 1. And then if client try to connect to you, then you can accept this. Immediately, then I know remote port and remote host IP and remote port numbers. Then I can continue to talk. I have a while loop here. Okay. Client. I also defined the client class. Initialize it so that TCP client C, TCP/C object is created, and then I can talk. Here I need to put specific IP number. In this case, I need to put these IP numbers. Okay, because this is server TCP program does not need to specify its own IP numbers, of course, right? But client should point at specific IP numbers. So at the client side, we need to specify here a specific port number, a specific IP address, and specific port number. This port number that is opened by the server. Remember 2545, that is opened by this server. Same port number. That way, the Raspberry Pi server open that port, then your client from your laptop signal goes into the very same port of the Raspberry Pi. Therefore, Raspberry Pi server can respond. All right. So let's do the program. So I already had here the project 24. I put there TCP server, cat TCP server.py. Remember here bind quote and unquote, and port number 2545. It's the same as that one's. And I want to run this. Server needs to run first. Python TCP that, run it. So that is running. So I want to put this here and then push this a little bit aside. And I want to minimize this. And I believe I already started here. So on my directory, 545 distributed application device, I have a RPi underscore TCP directory. Yeah, on that directory, I have TCP class client.py. This is the server-side program that already running here, right? And I want to run the client. TCP class client.py. Okay, so I want to do this. The server is listening. Server, I didn't do anything here, but if you say, hey, connected, you can put that the comment, that prompt here, but I didn't do anything until I say something. So I can say, hello, TCP server at RPi5. Then it can echo, because in the program I said when I received the messages, I want to print here received, and then data that I received from the client. This is my comment, and followed by the data that I received. So here it should say here received, and then this is the message. Hello TCP server at RPi5. So I want to send this from the client and watch here at the server side. Hit enter. So at the server side, now connected here received. Here received. Hello TCP server at RPi5. And also this server can talk back to this client. So I can say, nice to meet you, client. If I hit enter to reply, then it'll be echoed here, because here at the client side, I also said here returned from the server followed by the data. So it'll be echoed here. So watch that. So when I hit enter and goes to the client, it says returned from the server. Hello TCP. No, he replied. So replied. Nice to meet you, client. Right? I can say also, I'm good. Then it shows I'm good. Me too. Then it says replied, me too. If this guy's, hey, I want to end to quit, type end. And then here also type end, then it'll disconnect it. Okay. Now you know how you can do. Here we do simply the user type the message to share between client and server. But in response to the request from client or request from server, you can do further action on your code here and look up your file server and some data instead of your the hard-coded typed message, you can send some of the data that's available on your Raspberry Pi or your laptop to your opponents. Okay, so in that way, data can be shared over the internet, over the distributed applications. All right. So, what is the homework? Your homework needs to show like this. I want you to show your Raspberry Pi here. By the way, I want you to say here this, and I will put here. Then I can say, hello, I am John Yoon. I want you to say that. Hello, I am your name. Okay? So I want you to type these images. I'm not, this, you can take your photo images, or you can save this screen. You can save this screen, right? Because this guy already on your screen. You can screen copy of this. Either screen copy or your the photo images. So that needs to be submitted. That is your homework assignments. Okay. Good luck, and I will see you next time.